Let's start with number 1. Victoria. So saying for number 1, the equation of the motion of a certain driven damped oscillator is given by that. Those double dots, what do they represent, these dots?
Like acceleration.
This one is what?
I said on the double dots represent acceleration.
And then the first one is what? The one dot represent?
I think it's velocity.
The velocity, yes. So basically what you are supposed to be knowing, you must know the conditions for critical damping, under damping, etc. And when it's damped, what are the conditions? So I will show you when you are doing the calculations. It's just like those quadratic equations that we used to do when we are having real roots, repeated roots, and we are having complex roots where real roots are non-real. So it normally goes back to here. So you can see if we are going to solve this one, we are given, and initially the particle is at rest at origin, find the subsequent motion. So it's basically we are just solving the differential equation. That's all what we are just supposed to be doing here for 10 marks. So let's solve it. It's just a differential equation. So what you are solving is just finding the equation, describing the motion. So that x, it's x of t, which means it's relative to time. So our equation, where is x there, it will be x of t. That's why that x dot, you are going to write it as, whenever you are given x dot like that, that's where you come and say it's equals to what? Dx dt, which is the same as we are differentiating d dt of the position. That's why you are going to get, this one is your velocity, like what you indicated. Okay. So we must know the basics here. That's why I'm saying this x, it will be respect to time, not just an x like a variable. It's x of t, which means time. So that's what we are finding here, what we are going to solve for. So we want to solve for that x of t for a damped oscillator. What information are we given? So what we are given here is the word equation, the differential equation, which you can split this first part, can solve only this part first. This one, you are going to solve it when you are looking for the y particular. Did you do differential equations?
What do you mean?
Have you done differential equations in maths?
Yeah, differentiation, yes.
Not differentiation, differential equations. Differential equations, whereby they are saying this equation is homogeneous, separable. Have you done?
We haven't. No.
So that's where you are going to be applying that knowledge of differential equations. So that's what you are going to be doing. So you using differential equation. So the equation of motion of that oscillator, this is the equation of the motion of the oscillator, this one, which we are given. And where are we getting these conditions, which are they are saying initial conditions are x0 and also at time when x is not, which means the position is also what? 0. And when you differentiate the position, which means you are going to get the velocity. The velocity initially is also 0. That's what they are saying. Where did they get this information from? They got the information from here, where we were told that initially the particle is at rest at origin. When the particle is at rest, what does that mean?
It's not moving.
It's
So
not moving.
velocity is 0.
Velocity is what? Is 0.
It's
So
0.
yes, these are the initial conditions. So the velocity is 0. So if the velocity is 0, so they have told that it's also that is at origin. What does origin mean?
Isn't it displacement? Like
What
position?
the displacement is what? It's 0, isn't it?
Mm. X 0. X is equal to 0.
That's why they said x is equals to 0. It's at origin. So x naught is equals to 0, which means it is at origin. So at time naught, it's at 0. It has not moved any point whereby to say it's starting at 5 or it's starting at 2. Here it's starting at 0. And also the velocity at that point, we have been told that the particle is at rest. So you know that x dot, which is the velocity at that point, when time is 0. Is there someone who wants to join?
Uh, I didn't ask anyone. Like you said no. But
Okay.
I have a friend.
Because I'm seeing there's a bit of noise here. So let me check what is it. All right, it's fine. So let's go back to the question. So we have identified that the initial particle is at rest. The displacement is starting at origin, which means it has not moved. It's starting at 0.0. So which means the velocity is 0 and x naught is equals to 0. So those are the initial conditions, these ones, which we are using here, where we got these initial conditions. Initial conditions, the displacement, which means it's starting at origin. So this is the information that it is starting from origin. What we know is starting from origin. And because the particle is at rest, it means that the what? The velocity is what? Is 0. So this is the particle at rest. It's not moving. So if it's at the particle is at rest, we know that the velocity is also what? 0. So do you see where we get the initial conditions?
Um,
So these are the things that you must know before you write or you try to solve the equation. You need these two conditions. So yes, they came from the text that was written. The particle is at origin, or they can tell you that before the particle moved already, it was at a distance of 5 meters. Then you know that at x0 is equals to 5. If the displacement was not at origin, then you will know that x of 0 was at some point, which is not origin, maybe 5 meters or 6 meters. Then you will know your initial condition, x at 0 times 0. What was the displacement? 6, if you are given that case. But in our case, we were told it's at origin.
when you say x of 0, the 0 that you're putting in the bracket, what is that 0 for?
The 0 is for time. When time was 0, before the time moved, or before we start to for the particle before it started to oscillate, to move back and forth. Remember?
Okay.
Before it started to move back and forth, where was this particle? Where was the spring position? So it was positioned at a point at the origin. That's what they are just saying. But if it was not at origin, then they will tell you that at time, not the starting time, that 0 there is representing time. Time, T. Yes, the 0 is for time not, T not. T equals to 0 seconds. This is the time. What that 0 mean represents. Answered. So this was the first step. Then now you need your information for differential equations. So since we said we are calculating the general solution for this equation, then you must know how is that general solution going to be formed. So which means the general solution of a non-homogeneous linear differential equation is the sum of homogeneous solution and a particular solution. What do they mean by this? Which means the solution to our differential equation, which is the general solution, we are going to get it as a sum of two equations, which means one, we are going to have a homogeneous solution plus we add it to the particular what? Solution. So this is how we are going to find, as we are looking for this one, the general solution for that equation, differential equation that we have here on top, this differential equation. We want the general solution to this differential equation. Get it? By saying general solution, we mean any value. It's like you are solving an equation, you are solving an equation for x. So you want the value that will suit, or when you substitute that x in that equation, this equation will be satisfied. You get what we are saying here?
Okay.
Yes, we are looking for these values. But in our case, it's a differential equation. So it will be a general solution that when you substitute that equation, when you substitute it, that when you find that your x of the general solution will be in the form of x of t will be equals to what? Yeah. So that if I differentiate it the first time, this one, it's saying differentiate second time, twice. So that if I differentiate this general equation, which I have found twice, then I plug it, then I put it here, then I come and differentiate again once, this general solution which I would have obtained, I replace it here, where there is the first, only the x with one dot. Then that general solution, I multiply it by 8. You get it? So that it satisfies that equation that is given there. That is what we are just trying to do. We are just trying to solve for the values which we are going to replace that will satisfy the equation. So a general solution is formed by two things, which is a homogeneous solution and a particular solution. We are going to show you how we are going to calculate this homogeneous solution and this particular solution, how we are going to get it. Right, a homogeneous solution is found by solving the characteristic equation. This is the characteristic equation which they are talking about. The characteristic equation, we are only solving this left side. That is what, when you solve only the left side, we find the what? The homogeneous equation. Then we add it to the particular solution. How do we find the particular solution? The particular solution can be found by using the method of undetermined coefficients. I will explain it to you while we are going to be doing it. So these are the two equations that we are going to add. You are going to add this equation plus this equation. Then we get the general solution. If you add these two equations, then we are done. So we have a homogeneous solution. We add it to the particular what? Solution. Then we get the general solution, this one that you are looking for. That general solution is when I differentiate that general solution twice, I replace it here, plus 6 times I differentiate that general solution once, plus 8 times that general solution, I must get what is on my right hand side. That is what they mean. That's what we are just, only that. So how are we going to be doing it? How we are going to solve? So solve the homogeneous equation to find a particular solution, add them to obtain general solution. We are just repeating that. And then apply the initial conditions. The particle was at rest and the particle is at equilibrium, which means x naught is equals to 0. And then dx dt, which means the velocity is also 0. These are the initial conditions which we have talked about. Any question is so far?
No.
How and what we are supposed to be finding? Yes. Let's move now. So step 1, we are going to solve this homogeneous equation. So like I indicated, the homogeneous equation, you are only solving the left part of the equation. Remember, this equation at origin, which we are solving, it's x double dot plus 6 times x dot plus 8x is equals to 7 cos t. So if you want the homogeneous equation, we are only solving this left part. Then we equate it to what? To 0. Did you get that one?
Why are we equating to 0?
You equate to 0 because that's how you solve a homogeneous part. When you want to solve the homogeneous solution, you ignore this one. You ignore the 7 cos. Then where the 7 cos, you come and put what?
0.
0. That's how you solve the homogeneous solution first. Once you have found the homogeneous solution, now when you solve for the particular solution, you also do the same. You ignore now the left what?
The left side.
Then you only deal with the what?
7 cos t.
Yes, that's how we are going to do it. So when you solve for those two, you ignore first the right side, then you solve the homogeneous equation by equating only the left to 0. Right. Then the right side, when you are calculating the particular solution, that's when we are going to use the method of undetermined coefficients, which they mentioned here, when you are calculating for the particular solution. Then I will show you how I'm going to use the method of undetermined coefficients. Remember, we said for the general solution, we are adding, in other words, we are saying y general solution, or we can call it x, since it's x, the function is in terms of x. So we can say xg, meaning the general solution in terms of x of t, g plus, sorry, not plus, is equals to the x of t, which is homogeneous, h, plus the x of t, which is the particular solution. These two, they must combine together to form a what? X of t, which is general what? Solution. Do you get it? That's what we are doing here. Such that once you find this equation, the x general, when you replace it here in this equation, it must satisfy that equation. It's like when you solve for x, once you take that x, you put it back into the original formula. The left-hand side and the right-hand side must be what?
Equal.
Must be equal. That's what we are just doing here. Right. So let's solve the homogeneous what? Equation. Now we are solving the homogeneous equation. So we have equated this equation to 0. So now we want to solve this equation. So what do you do? Since you are seeing the double dots there, these double dots, R is representing the root. You want to now find the root of this equation, just like when you are solving a quadratic equation, isn't it? R here is representing the root of the equation. So R is representing the roots, which are the solutions of that homogeneous what? Equation. So where is the quadratic equation coming from? The quadratic equation is coming from the sense that since you are seeing a double dot, those double dots, it means second derivative. So this is the second derivative, R squared, plus 6 times the first derivative, which means you only put what? R, which is this R only, which is there. So when it's second derivative, which means it's R squared, plus 6 times R, which means R is just a root, which means X dot is just the first derivative. So it's not going to be R squared, just 1R. R to the power 1. R to the power 1 is just R in terms of exponent. What is R to the power 1? It's just,
It's R.
yes, that's what it is. That's
No,
okay.
I can't hear you.
You hear me?
Yeah.
How far now?
Yeah, I hear you.
I think it was network. It was network. All right, let's continue with our problem. So I'm saying now you want to convert this equation into a quadratic equation so that you can solve for the solutions for this homogeneous equation. Why is it homogeneous? First, you have removed that right-hand side, which was 7 cos t. Where there is 7 cos t, you equated to what? To 0, always. That's why it's homogeneous what?
Okay, sure.
Equation. But we'll come back to that 7 cos t. But for now, we are only solving for that homogeneous equation only, so that we can find the solutions for the homogeneous equation, which is, this is the homogeneous. Why is it homogeneous? Because we have equated it to 0. That's what we mean there for now. So where is R coming from? R is coming from the sense that we want to calculate the roots of the equation. In other words, the solution to the above equation, which is the one here. We want the solutions to that above equation. So that R is simply representing roots. Why is it R squared? Because we have differentiated second time, which means it's R squared, second derivative. First derivative, R to the power 1. This side, there is no derivative, R to the power what?
0,
0. What is R to the power 0 be?
1.
1. 1 times 8 is just 8. That is where it's coming from. So these R's, they are indicating the order of derivative. Is it the first order derivative, second order derivative, or there is no derivative at all, which means it's R to the power 0. Here there was no derivative. That's why 0, 1, 1 times 8 is just 8. Any question here?
No.
Right. Now that we are in the form of what? Quadratic equation. You use your mathematics for metric now to solve this quadratic. Are you able to solve it?
Yeah. Let me do
Yes. Tell me what you are going to get. R squared plus 6R plus 8 is equals to 0. Solve it quadratically, then you tell me what you are going to get before I move to the next slide.
It's going to be r plus 2, r plus 4 is equals to 0. So r is equals to minus 2, or r is equals to minus 4.
So you are saying R is equals to minus 2, or R is equals to what?
Minus 4.
Or R is equals to minus 4. So these are the roots of the equation for that. So let's check the values that you have given us. R minus 4, R minus 2. These are the equations, the solution, the roots which you have given us. So they just indicated that these R's, they are different. It's root number 1, root number 2 by just indicating these subscripts. Root 1 and root 2, which means solution 1, solution what? 2. Can you see the subscripts? R1, R2.
Mm.
So they are just representing that this is solution number 1, solution number 2 to those roots. All right. So once you have solved it quadratically like that, these are your roots. You have solved it by using quadratic factorization. Now, you form that homogeneous equation. How do you form this homogeneous equation? It is a basic that if you want to solve that homogeneous equation, our equation was x general, which means just x of t, which is the homogeneous equation with an h. We are not yet at the general, because general we said we're going to add the homogeneous plus the particular solution. So for now, we are looking for the homogeneous part. So it's equals to the first constant, which is a, can be any number. E always to the power r t, which means r1, which you found, plus another constant, which is b, always multiplied by an exponent e to the power, the second root that you found, which is r2, multiplied by t. That is the general solution, how we are going to find it. Or you can write it like this, which is on top, to say a, you can use constants. Where there is a, you can say maybe I want to use constant number 1, constant number 2, it's up to you. So if you want to use constant 1, constant 2, you are allowed. If you don't want to use constants, you can say a, which means a and b are what? They are just constants. You get it?
Mm.
So this is how you find the homogeneous solution. This is the standard. Now we want to replace the values that you got. Where there is R1, now you don't put R1, you put the value now. So you are going to write C1 if you want to write C1, or if you want to write A, they are just constants. You are not penalized for these letters which are in front. C1 is just representing constant number 1, C2 constant number 2, multiplied by e to the power minus 2t. So that 2 is coming from the root, which we found.
Mm. Okay.
That R1 is coming from here, then minus 4. It does not matter. You can even
So
say
that's not with.
1, yes, as long where you replaced those R's, it's correct. You
Okay.
get what? Yes, you can start with the C1 e to the power minus 2 plus C2 e to the power what? Minus 4. It's still, yes, it's still correct. It's still correct. But the constant that corresponds to that root, it will come, it must be the same. I will show you how it's going to be the same. But this is the general. So now once you have found your roots, you want to replace them here. How are you going to solve for A, this constant, and B, this constant? That's when you are going to use initial conditions. Those initial conditions that we found, you still remember?
Yes.
That's where you are going to solve for A and B using the initial conditions. So for A and B, we use the initial conditions to solve for A and B. But this is the general of how you find a homogeneous equation. So from now, you must be in a position to find a homogeneous what? Equation for any given wave function that will be given for any oscillator. You must be in a position to find the homogeneous equation. How do you find the homogeneous equation? By just equating the left-hand side to 0. That is the first thing. After you've equated the left side to 0, then now we want to calculate the roots now. Represent where there is second derivative, it's r squared. First derivative is just r. There is no derivative, which means it's r to the power 0, which is just 1. You solve your equation, obvious it's going to be a quadratic equation. So you must know that. Then we are here now at the homogeneous part of the equation. So now we have substituted our roots, which means we are here now. That's where we are at this step. We have substituted our roots now. So we are at this step. Now, from that step, we want to solve for the constants. What is C1? What is C2? Using the what? Initial?
Condition.
Yes, that's what we are doing. That's where the right. Let's go to the particular solution. Before we solve for C1 and C2, let's go to the particular solution, which was on the right side. Remember, it was the right side was what? 7 cos t. The right side was 7 cos t. So with 7 cos t, you don't equate to 0. You use the method of undetermined what?
Undetermined
Coefficient.
coefficient.
Yes, to solve for that particular solution. So I will show you how do you use those method of undetermined coefficient. But for a homogeneous solution, you just equate to what?
0.
0. So you must note that. That is what you are just doing. But for a particular solution, you must use undetermined coefficients. By undetermined coefficients, you look at the form of your right-hand side. If your right-hand side is having a quadratic, or if your right-hand side is having an exponential, or if your right-hand side is having a trig function, those are the method of undetermined coefficients. What do you do? What kind of function are you going to use as your trial solution? Which means you are going to do trial and improvement, trial and improve. So sometimes you might find that on the right-hand side, it's not only quadratic, it might be x e to the power t, or you can find that on the right-hand side, you are having x squared, or you can find on the right-hand side, you are having the one which was given 7 cos t. So can you see that there's difference there in terms of functions that you will be having? Sometimes you might only e to the power t. So the method of undetermined coefficients helps you to choose what kind of function which will be general that you are supposed to choose. So you don't just pick any function. So as a trial or a particular function to replace your right-hand side. Remember the right-hand side, we said we don't equate to 0. Here it's a particular solution that we are trying to choose. But while we are choosing, you resemble whether are you given an exponential or are you given a quadratic, or are you given a trig function? In our case, we are given 7 cos what?
T.
T. So which means the particular solution that we are going to use as a trial solution, we call it a trial solution, which we are going to use that particular solution as our trial solution. It will be in this form. It will be in this form. Why is it going to be in that form? Because we know the roots for a trig function, these ones are because of there will be complex roots or exponent. In metric, we used to call when roots are non-real. For example, square root of a negative number, square root of -5, -10, whatever. These are the roots which gives us this kind of particular solution, whereby we are having A as a general, it's just a constant, cos t plus B sin t. That's how you write this right-hand side before you solve for any values for A and B. You just write it in general. Just like the way I did this one. I wrote this homogeneous just in general. Before you replace the values of R or constant 1, constant 2, and R1 and R2, first you must have a general. What is the general? The general is this one, which I just ticked in. That is the general of a homogeneous equation. After you have solved your numbers now, that's when you can come and replace. R1 is -4, R2 is -2. Then you can put the values back. Similarly, you use the same logic here when you are solving for particular solution. When you see cos on the right-hand side, you must know that cos and sine, they always go together when it comes to non-real roots, because this is the square root of a negative. Now it's a complex root, which means I must know that I must use A cos t and B sin t. That's how we choose the particular solution. So, so the first thing, now you differentiate. Since you want to solve for A and what? And B, you differentiate the first derivative of that particular solution. So you have found that the first derivative of the particular solution is giving you what?
First derivative of the what? Particular solution.
This one. When you differentiate this one, what do you get?
It's
We are differentiating
minus
with respect to time. In other words,
minus
I'm saying, yes, say it. You are getting what?
minus A sin t plus B cos t.
Yes, plus B cos t. It will be minus A sin t plus B cos t. So that's what you are going to do. You differentiate with respect to time once. Why are you doing that? Why are you doing that? For the particular solution. So once you have done that, when you differentiate cos, you get what? Negative sign. Differentiate sign, you get positive cos here. And when you differentiate again, which means sine, it becomes cos. And then cos becomes what? Minus sine t. So this is the second derivative of the particular solution only. The general, without putting the 7t, 7 cos t or what, we are just talking about the general of the particular one solution. We have not put any values there. We are just talking in terms of general. All right. Then from there, we go to, we are finding now the values of the constants. That's what we are doing now. So substitute that particular solution and its derivatives into the original what? equation. Yes, into the original equation. So we are substituting those values into this original equation. Okay, so let's come. So here we have found that our x second derivative, we have found it to be minus cos t minus b sine t. So we are substituting the first derivative of that particular solution minus a sine t plus b cos t. So let's substitute into the original. So this is what they are referring to as what? The second what? Derivative, isn't it?
Mm.
There, where is this 6 coming from? The 6 is coming from here. Can you see this 6?
Mm.
This 6 is coming from here. So after we are done, we are going to equate that particular solution to 7 cos what?
T.
Yes, that's what you must know. We are going to equate to 7 cos t. So you do the same, but for only the homogeneous equation, we solved it quadratically. So you must know these tricks. That when I'm solving the equation for the homogeneous, I equate to 0, then I solve it in the quadratic form. We are having r here. Where was our r? For here, for r. Then you replace, then you get your values in terms of quadratic, after the quadratic equation that you factorize. But for a particular solution, first we said you must first choose the nature of that particular solution using the method of undetermined coefficients. If the right side was e to the power t, it changes everything compared to 7 cos t. I will make my particular solution be xp is equals to e to the power what? T or rt. So that I differentiate it first time, I differentiate it second time. But in our case, there was 7 cos t. It's a trig function. What do trig function represent? They represent that the root for that function was non-real. Yes, it was a square root of when you quadratic equation, when you find out b squared minus 4ac, the middle term is giving you negative. Then you know we are going to use cos a cos t plus b sine t. Right. You differentiate first time, differentiate second time, substitute these values, these derivatives into the original. So we have replaced these ones into the original. Right. What do we do next? We equate now coefficients. All right, here we did not replace. Let's replace, we see what we are going to get while we are also doing it. All right. Are you writing these things down?
Yeah.
All right, when we equate the left and the right, so this is our left. When we add the first derivative, the second derivative, and then plus, we multiplied it by 6 times. When we expand that bracket, 6 times the first derivative, then you say also plus. There is another function that is left out, which is plus what?
8.
8 what?
8x.
What is our x? What is our x here? X
Isn't
is
it
what?
1?
X is not 1. This is our x. This is our,
Oh, yes.
that is the x. X is not 1. So we are adding 8 times this. And then this one, we are saying times 6. This one is times 8. This one is times 8. This one is times 6, which means the first derivative is the 1 times 6. Then the double derivative, we are not multiplying with anything. Then you
How
replace
much?
it.
Oh, yeah.
Yes, you are not multiplying with anything. So this is times 8. And then this times 6. And then this you don't add, multiply anything. So when you add times 8, which means 8 cos t plus 8b sine t. Then this side we are getting minus a sine t minus 6a sine t plus 6b cos t. Then when you add everything, you are going to come to the point that we are having minus a plus 6b plus 8a cos t. They factored out here cos t, everything that was having cos t out. Then they also factored out everything that was having sin t. So this is having cos t out. And we factored all the values that were having sin t out. Can you see? Cos t and sin t. After you add everything. So I'm just telling you what you are going to have here. When you add this bracket, 8 times that plus 6 times that, then plus the first derivative, which you are not going to multiply with anything. What do you do next? You separate the constants. These are the constants, A, B, and A. All the constants which are having cos t, you separate them together. All the constants which are having sin t, you separate them together. Then you equate them to 7 what?
Cos t.
Cos t. You equating to 7 cos t. Can you see that on the right-hand side, we don't have sin t? Do we have sin t here on the right?
No.
No. So it's a hint and it's solving your problem already, because you want to make the left and the right equation the same. So already it can give you a hint which equation you are going to cancel out, etc. So we want to solve for this. You want to try it.
Let me write down.
You want to try to solve this equation so that you can see your mistake or here and there if once we correct.
Wait,
Right?
I'm writing.
Yes. And do you know what we are solving for?
Cos.
Do you know
Cos
what we are
t
solving? No, we are not solving for cos t. We are looking for the constants, A and what?
and b.
That's what we are solving for. Cos t is not our problem. Our problem is A. What is the constant A and B? That is what we want to look for, A and B. So use your knowledge of mathematics, cancel out the common factors which you are seeing, then you solve for A and what? And B. Then you solve for A. I'll give you 1 minute, 2 minutes so that you finish solve for what do you find the values of A and B equals to in that equation, which is given above. So in other words, you are looking for the values of A and B. Do you want a hint?
Am I not going to, what's this? 7 cos t is gonna be, no. I'm gonna say 7a plus 6b cos t divided by 7 cos t and Wait.
and what? Okay, let me help there. So you are equating, for example, here, you are solving for A and B, isn't it?
Mm,
So you equate those things which are having cos t together first. Just solve the ones with cos what? T, isn't it? Isn't it on the left-hand side, you are having cos t.
mm.
On the left-hand side, you are having what?
Cos T and sin T.
Cos t and sin t, isn't it?
Mm.
So if you want these equations to be the same, left and right, you want to solve for A and B, that will make left and right equation the same. Remember, the right-hand side can also be written as plus. The right-hand side, you can also write it as plus 0 sin what?
Sin T.
Sin t. Because there is no anything in the what? In the sin t. So then you equate the sign together, then you also equate the what? The cos on their own. Do you get the logic? So that the zero, you make two equations now. This you equate to this one. Then the first equation for cos, you equate it to 7 cos t. In such a way that the cos here, they will cancel, this one will cancel and that one. So that you are having 7a plus 6b is equals to 7. This step, you make it your equation number 1. Are you there?
Yes.
Do you understand it?
Yeah, I do.
Yes. Then you take the sign, you equate them together. You cancel the signs, this sign, because the other one is on the right-hand side. So sign divided by sign is what? It's 1, isn't it?
Mm.
Cos divided by cos, dividing by cos both sides, you are going to be left with 1. What is 1 times 7a plus 6b? It's just 7a plus 6b. What is 1 times 7? It's just 7. So you have just divided by cos. Then you equate also the sign. Minus 6a plus 7b sin t is equals to 0 sin t. Divide both sides by sign, which means the right-hand side is 0. Then you'll be left with 6 minus 6a plus 7b will give you what? What
I'm
will
writing down my
minus 6
answers.
minus 6a plus 7b is going to give you what? It must give you 0, isn't it? That is your equation number 2.
Kevin?
Equation number 2. Ask.
No, it's okay.
Do you know how these equations they've come from?
Yes, that's what I'm writing now.
So we are solving A and B for the particular solution. This is our particular solution. The general form of the particular solution is xp A cos t plus b sin t. Now we are solving for those particular solutions. By first you differentiate it once, you differentiate it twice, replace it, substitute it into the original equation. Then you equate it to 7 cos t. So now we are solving for A and B. That's what we are doing now. How did we solve for A and B? We said separate all those equations in the cos together, separate those coefficients in the sign with the sign t on their own. So the
Oh,
cos, yes, once you have separated, equate to the right-hand side, which is cos t. When you are equating to the right-hand side, you must know that if you are not given sin t on the right, you can write it just as 0 sin t, isn't it?
mm.
Yes, so that you can equate all the variables, so that you are having a cos on the left and the sine on the left. At the same time, you are having a cos on the right and the sine on the right. So one way of writing sine on the right, even if you are not given, is just 0 sine t. That's why the first equation is 7a plus 6b is equals to 7, because we equated coefficients having cos t. These were the coefficients that were being multiplied by cos t. You equate again the coefficients which are being multiplied by sine t. On the left, you equate them to the coefficients which are being multiplied by sine t on the right. On the right, we have 0, and then on the left, we have minus 6a plus 7b. Then you solve these equations what? Simultaneous.
Tennis.
Two equations, two unknowns. So you can solve this equation simultaneous. I'm giving you 2 minutes to solve it simultaneous. You tell me what are the values of A and B. I'm giving you 2 minutes to solve those equations simultaneous. You find the values of A and B. Are you still working it?
Yeah, I'm almost done.
Yeah. You want the values of A and B.
B is equals to 42 over 36.
B is equals to 42 over 36.
Yeah, I'm still calculating A.
B is equals to 42 over.
36.
Now we are calculating for A.
Mm.
Calculate A. Let's see.
A is equals to 0.
A, you found A equals to 0.
Yeah.
But is that possible that B is 42 over 36, then A is 0? Okay. It's fine. Let's check the answers. So B is 6 over 7. So here you simplify the fraction, isn't it? 42 over 36. When you divide by the highest common factor, what do you get?
We are getting 7 over 6.
So which means you did not solve the simultaneous correct. How come you get 7 over 6?
Let me check something.
Mhm. How did you solve the simultaneous?
I made it do it.
So the trick here, Yuda, is this one. Let's come here. Let us not waste time. Let's go to equation number 2. Can you see equation number 2?
Yeah.
So from equation number 2, we are having minus 6a plus 7 what?
B is equals to 0.
Is equals to 0. So in other words, 7 what? B. 7b is equals to what? Minus
6
what?
B.
Equals to 6a, sorry. Equals to 6a. So if I want b, I'm going to divide by what?
7.
By 7. So after I divide by 7, what am I going to get? What is my value of b? B will be equals to what? 6 over 7 multiplied by a. That is the b. 6 over 7 multiplied by a. Then I come and I replace that 6 over 7. Wherever there is b, I come and replace now in equation number 1. So where there is b here in equation number 1, I want to solve for a. I replace b with what?
6 over 7.
A, yes. Then where there is b, replace the b with 6 over 7a. So 7a plus 6 multiplied by 6 over 7a is equals to 7. Then you solve for what? For a. 7a plus 7a plus, here what did they do? They just multiplied both every term by 49 to get rid of the what? The fraction. So this term times 7. Then you do the same here times 7. What you do on the left, you multiply each term by what? By 7. Why did they multiply by 7? To get rid of the fraction on the, so that they make the equation linear. So the 7 and the 7, they cancel. After they cancel, which means now we are having 6 times 6 multiplied by a, which is what? 36a. 7 times 7a, 49a. 7 times 7, 49. Are we together?
Mm.
So they got rid of the fractions by multiplying by that denominator on all the terms. You don't multiply only there, you multiply on each and every term because there is a plus here. There is a plus. So you multiply each term by 7. So we got 49a plus 36a, 85a. What is 85a equals to 49? Therefore, you divide both sides by what? By 8. Divide both sides by 85. So if you want to find the value of a, will be 49 over 85. So here our a is equals to 49 over what?
Over 8. 85.
Then if you want to b, it means b equals to 6 over 7 multiplied by a. So what will be b equals to? A multiplied by, so you just multiply here by 6 over what? 7 goes into 7 how many times? 7 times.
Even 42 over 85.
42 over 85. So this is your b, which will be 42 over 85. So b will be 42 over 85. And then a, we said a is what? 49 over 85. Okay. So we have found the constants. Assume the particular solution is of the form A cos t plus B sin t. So we have found the derivatives, we have substituted the terms, put the coefficients everywhere where they are supposed to be, substituted, multiplied by the denominator. We found our A. Now we are solving for A and B. We found that A is that, which means A is what? Calculated. What is B? We multiplied B by 6 over 7. We found this was our what? Our B. Then from here, we now know our A and B. So on in our particular solution there, where it was saying A cos t, now you replace the A. Now you know the constant. What is the value of what? A. Where it was saying plus B sin t, you replace the value of the B. Now you know the value of the what? Of the B. That's what we are just doing as a general. So this is your X particular. So we say the general, we are adding the two equations, the homogeneous plus this particular solution. So we have found this equation, which is number 1. That was equation number what? Can you see it?
Yeah.
Our particular solution. Then
Yes.
we have our general solution. We have our general solution, our homogeneous solution, which we calculated using the quadratic, the homogeneous one, using the quadratic roots. This one, the homogeneous. We calculated this one as well. Don't forget, we have calculated this one when we were equating the quadratic roots, this one. And equated there. All right. So we are going to join these two equations. Why are we joining these two equations? Because from our definition, it says that solve the homogeneous equations, find the solution, find the particular solution, add them to obtain what?
General solution.
To obtain the general solution. You get it? So the initial conditions, they apply now on the general solution. Those initial conditions that we were talking about, where we are going to find C1, C2, etc. They apply on the general solution. That's what we are going to be doing now. So now what's left is to combine. Let's combine now to get the general solution. So this is what we are going to do. We have solved for A and B. The values, we have obtained them. A is 49 over 85. B 42 over 85. This is our particular solution after replacing the values A and B. Now we want to find the what? So the general solution, we are adding the homogeneous, which we equated the left side to 0. When you add these two, you form what you call the general solution. It's because of the adding. Because of the adding. Because of the adding. Right. Then from there, we add what we have. From the previous one, where we said A plus B to the power R1 T, R2 T, these are the values of R. These are the values of R. -4, the other root was -2, and E is always the exponent. Exponent to the power. Don't forget the T because it's a function with respect to time. C1 and These are just constants A and what? And B. The reason why they did not use A and B, because on a particular solution, there is also A and B, but it does not matter. You can also still use C1, C2, or A and B. It does not matter because for the constants of particular solution, we solve them first before for the general one. So this is the general solution. But we must solve for these constants. These ones. We must solve for them. We must solve for those constants, which is A and B. This constant, like what we did on the particular solution, it must be a number, this one. This one is now okay. This one is now what? 1. Can you see?
Yeah.
Then from here, we are going to use the initial value conditions that we obtain. The particle is at equilibrium, the displacement is 0, and the particle is at rest. The velocity is what?
Mm.
So which means if the velocity, you are going to differentiate this whole expression. Then you equate it to what?
0.
Then if they say the acceleration is what? 0. You differentiate the whole of this expression again, twice, which means you differentiate first one twice. Then you equate it to 0. You must get a 0. That's what they mean. So that's what we are going to do now. All right. X naught is equals to 0, which means the particle is at origin at time naught. That's what they meant here. The particle is at origin. What we said that time. So when the particle is at origin, which means at origin always it's 0. Whenever something has not moved, something is telling you it's at origin. You always start. This is your y, this is your x. If I say I'm at origin at time naught, I'm here. So my position is 0. That's why this time naught t0, this is my displacement. I'm here. 0. So what is it that they are going to do? They are going to say that from that general solution, remember now we are applying initial conditions now. That is the last thing. You come to the general solution. X naught, which means X bracket. Where there's T, I must put a what?
0.
0 is equals to what? Wherever you see a T, you are going to put a what? A 0.
0.
Instead of sign T, they need to be sign what? 0.
Sign 0.
55, sign 0. 49 over 85 cos what?
0, which is 1.
Then C to the power E, this one to the power what?
0.
0. This one exponent to the power what?
0.
So you find that everything to the power 0, it's 1. So you'll be left with C1 plus this one to be C what? C2.
1
This
plus
is
6 plus 49 over 85.
cos what?
Because 0
Cos
is 1.
0 is 1. What about sine 0?
It's 0.
So this vanishes. It goes. Can you see?
Mm.
So already you have an equation 1. What was x naught equals to? So in other words, this x naught was equals to 0. Because it was at origin, at time equals 0. So you equate that equation to 0. That is this equation which they are having now. They've equated to this 0. This is the 0 which they've put here at time 0. So that they can make this equation number 1. That's their first one. Equation. Equation number 1. 2 unknowns, C1 and what?
C2.
How many equations?
I have 3.
We have 2, not 3. For x naught and we are given that x, the velocity, the particle is at rest, which means the velocity is what?
Oh, yes. Yeah.
These are the only two initial conditions that we know. So two equations, two unknowns. You can solve it what? Simultaneous. You can solve it simultaneous. So now we want the other equation. This is the differential equation now. Why are we differentiating? Because we want to know that when xt at time naught, the velocity at time naught, t naught, it was at rest, the velocity was 0. That's what we are talking about. The velocity was 0 at initial, because this was at rest, isn't it? The particle was at rest at t0. So if the particle was at rest, the velocity is 0. How do you find velocity? You differentiate again this general what? Solution, which you obtained, which was having homogeneous and particular one. Now you differentiate it again. When you differentiate it again, you are going to get this equation.
I did it.
You differentiate with respect to t. Yes. Which means whenever I differentiate minus c1 e to the power minus 4 t, you get minus 4. That is the exponent multiplied by c1 e to the power minus 4. When you differentiate c2 e to the power minus 2t, you take the exponent, put it here in front, plus minus, which means it's a negative 2 c2 e to the power of the exponent. And when you differentiate cos, you get what?
So, sorry, get sign.
Sign.
Minus sign.
Cos, it's minus sign, yes. Then when differentiate sign, you get cos. Yes, so this is minus sign. So that is the negative, which is a minus sign, plus cos t. Then you substitute 0. So time x naught. So this is now where there is t, I must put a what? A naught. 0. At time naught, we know that this is what? 0. T, put a what? 0. That t, I put a 0. This t, I put a 0. Cos t, which means another what? 0.
Just 42 over 85.
So this is out, isn't it?
Yeah.
And then here, 0. What do we get here? And remember, the 0 is only applying the exponent, but this term is there. So don't forget that. This term is there.
I'm going to be left with minus 4c1 minus 2c2 plus 42 over 85.
Plus 42 over 85.
85.
So this will be your equation number what?
2.
Number 2. So copy equation 1.
I have it.
Equation 2.
I wrote it down.
So you can solve it.
I'm solving now.
Yes, I'm giving you 3 minutes. So what is C1? What is C2? So that we can finalize the general solution. Then we'll be done with the problem. So these 10 marks, you can see they are fighting back. It's not an easy job. It's not easy. Yes. They are fighting back. And it wants someone who knows the stuff. There is no guesswork here which can work. You must know. And you must know what to equate to what. When do I use initial conditions? So initial conditions is when you have the general solution. While particular solution, you are just equating, you solve for constants. Equate the left, equate the right. That's Are you done?
No.
You're wasting our time. I want to finish. All right. C1 plus C2, that was the first equation that we obtained here. Equation number 1. C1 plus C2, when you move that plus 49 over 85, it goes to the left. It becomes a what? Negative, isn't it?
Mm.
Then we have our equation 2. You move it again to the left there. You get minus 4C1 minus 2C2 is equals to a negative 42 over 85. So these are the two systems that we are solving. This is still your equation 1. This is still your equation number 2. Then from there, you solve for C1 and C2 using elimination. Multiply the first equation times 2. So let's multiply the first equation times 2. Everything there. You multiply times 2. If multiply times 2, the first equation times 2. So once you multiply the first equation times 2, which means 2C1 plus 2C2, 49 over 85. So when you multiply by 2, you don't also multiply the denominator. Remember your fractions?
Mm.
For 49, only multiply numerator times 2. The denominator multiply. That's how we multiply. So now we have 2C. We want to eliminate the C. That was the idea. So we are eliminating the C. For now, we are eliminating only the C. We want to remove C2. That's the one. That was the idea. So
For C2, I got 14 over 51.
C2, you got
14
over
over 51.
14 over 51.
Yeah.
That was C2.
Yeah. I guess it's wrong.
Yeah, maybe just mistakes here and there. But at least you tried. You get the logic. At least trying is better. Okay.
Mm.
So we eliminate C2. How do we eliminate C2 here? How do we eliminate C2? So it will be 2C2 by adding these two equations. How are we going to add these two equations? These two equations, they will look like this. It will be 2C1 plus 2C2 is equals to the numerator. We said we are going to multiply it, then it becomes what? Times 2. 49 times 2 give you what? 90. Negative 98, isn't it? Negative 98 over 85.
Oh,
That's what we are doing there. All right, that is the equation. Then the second equation is the bottom one, which was minus 4C1. We write it down. Minus 4C1, which is there, minus 2C2, minus 2C2 is equals to what? 42 over, negative 42 over 85. We subtract, so it's negative 42 over 85. So once we have subtracted these two equations, we want to get rid of C2. What are we going to do? We are going to add second equation. So the rule is saying add second equation, which means equation 1 to the second one. We are adding now. When you add minus 2C2 plus minus C2, what do you get? Minus, can you see? Minus 2C2 plus, we are adding. But what are we adding? We are adding plus, minus 2 what? C2. What do you get here?
it's minus 4 C2.
You get what?
Minus 4 C2.
We are getting minus 4C2. So instead of adding, what are we doing?
It's minus most.
But this one was a plus means adding. The first one is a positive, sorry. You are right there, but here there is a positive here. Positive, it's plus.
Oh,
Plus
so it's going to be 2C2 minus 2C2, which is 0.
Yes, thank you. I had made a mistake. That's how we are eliminating these two. They are out. So those ones, we have eliminated them, they are out. So that we can solve for C1. That's why they said multiply the first one times 2. That was the idea, so that you can eliminate by subtraction the other one. So you eliminate by subtracting. So this is out, 0. So what you are left with now is just 2C1 minus 4C1. What do you get?
It's minus 6 C1.
No, it's not minus 6. 2C1 plus. Remember, we are adding these two equations. The plus. Yeah. We are now adding these two equations. We are plussing. So 2C1 plus minus C1. What do you get it? Integers. You must know the integers. 2C1 plus bracket minus 4C1.
Minus 2 C1.
Yes, it's minus 2C1. Minus 2C1, which is this one. Minus 2C1, which is that one. Then on the right-hand side, minus 98 over 85 plus minus 42. So you are just adding. Then you know it's a negative number. So you get this one on your right-hand side. Then you solve for C1 by dividing both sides by what? 2. Dividing by 2 is the same as multiplying by what? By half. Is that not so?
Yeah.
Dividing by 2 is the same as multiplying by half. So here I multiply by half. On the right-hand side, I multiply by 1 over 2. Also on the left, I multiply by what? 1 over 2. But because there's a negative, I must also put a negative. Here I must also put a what?
Negative.
2 and the 2, they cancel. Negative and negative is positive. This is the positive C1. Negative and negative, positive. 2 goes into 140, 70 times. So the answer it will be 70 over 85. Then you simplify by dividing by highest common factor. 70 over 85. What is the highest common factor of 70 over 85? That's 5. 5 goes into 70 14 times. And then 5 goes into 85 75 times. So when you divide to simplify, you are dividing by highest common factor of 85 and what? 75, which is just 5. Here you divide by 5. But I'm sure your calculator will just solve it for you. You don't have to stress. The answer is just 14 over what? 70. That is your C1. Then you substitute back to solve for what? C2. Go back to the equation. You solve for C2 by just replacing the value. All right. So for C2, we are just putting the value for which equation did we use. You can use this one. 2C1 plus 2C2 is equals to negative 98 over 85. So we find our C2. Or you can use this one by dividing both sides by half, which is C1 plus C2 is equals to negative 85 over that. So C1 plus C2. Where did they get these values? Multiply each term by half. You want to get to substitute, so you come and multiply here. This equation times half. You also multiply that equation times half times 1 over 2. You multiply this one again times 1 over what? Over. Already we know we have a value C1. So now we want to calculate what? C2, isn't it?
Yeah.
So which means you just come, you say, we are left with C2 on the left. C2 is equals to half, negative half of 98, which means 2 goes into 98 49 times. So it will be 49 over 85. That is this part. Then we take the C1. Half of 2C1 comes to the right, becomes minus C what? C1. Then we solve it. C1, we know it's 14 over, so we subtract 70 over 85. That was C1. So this is our C1. Before it was reduced to lowest common number, it was 70 over 85. Before we reduce it, it was 70 over 85. So minus C1, you get the answer of C2. After you are done getting C1 and C2, now you can find the general what?
Solution.
Which is x of t. X of t in brackets like this. X of t. This is your C1. Simply e to the power r. This was your r, which was your first root, plus C2 e to the power rt, it was the root, e to the power r2t. This one was R1 T. The reason why here there's a negative is because C2 is a what? Is a negative. Can you see? C2 is a what?
Negative.
So that negative also affects here. Where they were saying plus, we are adding plus a negative now. That's why there's a negative.
Okay.
Plus. So this is our xt. This was our xt, the homogeneous one. Remember? Plus the x of t, which was the particular what? Solution, which we calculated. Then we found the general, which is t, which you are looking for. So when you add the homogeneous solution and the particular solution, you find the what? The general what? Solution. Yes. And these were the constants that we equated when we were calculating A for the particular solution, when you're equating sine together, the cos together. And then this one was the constant for B, when you're saying B cos t, sine t. Now we are using the values now. They don't want variables where there is cos t. This one was B sine t. So the variable t, you don't replace. You leave t as it is. You only change A and B, C1 and C2, R1, R2. Put the values. Find your general solution. So this is your X that will satisfy this equation, which we're looking for from the very beginning. What is the solution that is going to satisfy this equation? So if you take that equation, Yuda, put it here, you are going to find out the right-hand side is going to be equal to 7 cos what? Cos t. You take that general, derive it again, you are going to get 7 cos t on the right-hand side. That's what it means. So this is the x which they are looking for. What is the x that will give us 7 cos t on the right-hand side? So you come and you tell them that x which you are looking for is this one. That will give you a 7 cos t on the right. Differentiate this second time, twice, the whole expression. Then you say plus 6, you differentiate it once, plus this very equation multiplied by 8. On the right-hand side, you are going to get 7 cos t. That's what they mean. So this is the answer which they are talking about, which is x of t general. Any question for 10 marks?
No question.
So tomorrow we'll continue with the second one. So this one, I will share the recording. Then you can replay where you did not understand or where you need clarity. Then tomorrow, I will share a link for the second one so that you can master the things. But for now, I think you have a picture of where we are going, what you are looking for, and how we are supposed to be doing it.
Yeah.
At least it's a better starting point. So we'll stop for now. Then I will share the video. Then tomorrow I'll send another link for the second question, which was also for 10 marks.
Okay, sure. Thank you.
All right.
This question should be 30 marks.
Yeah, but in the exam, it must be fast. It must be fast. It must be fast. Otherwise, you won't finish. You see, there are many, and these steps, they want someone who knows, not cram work won't help. You must know after I do this, I'm going here, I'm going there. So once you want to claim it's a mess, straight 0.
I saw it because I was trying to follow chat. I didn't know anything. What is this T? What is this C? I was confused. I'm like, I don't know.
So at least now I've clarified, isn't it?
Yeah, now it's better. Even if I look at questions, if I try to study while I'm waiting for you, at least I have an idea of what I'm doing.
Yes, so which means I've done justice. I've
And
done
you
justice.
have some.
All right. So I will share the recording, then we'll give you another link tomorrow.
Okay, sharp.